Okay, so we've talked about what proportional is, right? What it looks like when it comes to tables, like tables and charts. We talked about if something is proportional, but there's a missing number, how to find that out. So we've kind of dove deep into stuff like that, but what does it look like when it comes to graphs? Okay, so this is what we're going to talk about in this lesson, all right? So graphing proportional relationships. There's a few things that you'll need to know, all right? So here we go. For our examples, we're going to go straight to our examples, all right? Let's take a look in our book at page 216, problem number 18. I'm sorry, number 8. I said 18, didn't I? Sorry.
Yeah.
I confused myself on that one, too. I listened to my voice and not my eyes. So it's 215, right? The starting point is 215, not 216. That's why I had confused myself. So take a look at number 8. Let me do a little zooming. Okay, for number 8, it says the number of pounds of walnuts in a nut mix is proportional to the number of pounds of peanuts as shown in the graph. Okay, now, it does not say this here, but here's something that I would like you to write down. Okay, and I can't believe that the advanced book doesn't mention this, but if you are looking, it just states that this relationship here after it was graphed is proportional. Okay, here's the way to know that it's proportional though. If you look at a graphed line and it's proportional, it falls under two conditions. One, the line is always going to be straight. If the line is jaggedy or crooked or whatever, it is not a proportional relationship. So, this being a straight line, so far so good. But it has to fall under two conditions. Here's the second one. Now, I do want to explain this because it does confuse some people, but if we take a look, this here, I could extend this line down here. I can actually extend this number line over here. Ladies and gentlemen, this is coordinate graphing. Okay? This is quadrant 1. So without those lines, it just looks like that. But realize that there's no negatives in this. There's no negative pounds of walnuts or negative pounds of peanuts. So that's why it's only in quadrant 1. All right? Which means this right here, that's the origin. All right, that's the origin. So on this particular graph, the origin's at bottom left, but you just have to realize it's really the center. It's just that they didn't give you the rest of the lines. There's no negative value on this. Now, let's go back to this. So here, to make it proportional, it has to have both conditions. Line straight, and the line passes through the origin. Okay, some people get confused. Well, but Mr. Wilkins, it's stopping at the origin. Well, yes, but you have to realize that in some conditions, some graphing of linear equations that have to do with some real world situation, that graph line will keep going. Okay, just like this is going. It just happens to be in this condition that isn't it. So that's why you'll a lot of times see where it says passes through the origin, even though it looks like it's just hit the origin. Okay. So, I don't know, but this is definitely something that you need to know. All right. So let's go on with the actual problem here. So it says, A, find and interpret the constant of proportionality. All right. So if we take a look at this, okay. If you take a look at this, constant of proportionality was something we've talked about, right? And I'm actually, let me go up here. I used up all that space. Shame on me. I'm going to go over here for this problem, though. Couple of things about constant proportionality. One, remember, it comes from y over x. Two, y over x is expressed as a unit rate, meaning the bottom number is 1. And the third thing is it happens to be, after you get the unit rate, it's the top number, meaning like the part of the ratio that's in the numerator spot, right? So, with that said, here's what we're going to do. Step 1, find out what y is when x equals 1. Look at, this is the x-axis. There's the 1. What is the y, guys? It's right there, 0.4. So when x is 1, y is 0.4. So our constant of proportionality is 0.4. Now comes step, this is all A, by the way. Here comes step 2. We just found the constant of proportionality. Step 2 is the interpretation. So here's all you're doing, guys. You're writing the interpretation of that with the correct units. So remember, y being 0.4 means that when x is 1, meaning when there's 1 pound of peanuts, you'll have 4/10 of a pound of, and y of course is walnuts, so of walnuts. Constant of proportionality and an explanation of what that means. Remember, constant of proportionality is what is x going to be, what is y going to be when x is 1. That's what that is. What is y going to be when x is 1? So the x-axis, right, is peanuts. So when there's 1 pound of peanuts, there are 4/10 of a pound of walnuts, because that's what the y is. Okay. Now, we're not done with the problem, right, because we still have part B. Questions on either one of those, though? Okay, so part B. Considering this is all one problem, we'll just keep going with our steps. Step 3. It says, explain what the points 0, 0, 1, 0, 4, and 7.53 represent. So, here's what it is. Remember, in coordinate graphing, we've talked about this plenty. The first coordinate is x, the second coordinate is y. So, when there are 0, the x is 0, right? X is pounds of peanuts. When there are 0, we'll abbreviate pounds, of peanuts, there are, and then the y is 0, so 0 pounds, abbreviation again, of walnuts. Okay? This is a 7th grade standard, guys, so I have to make sure that I let you know. This is going to be pretty repetitive. Here we go. The next one. And this is all step 3. It's exactly the same thing. It's just the number value is changing. When there are, now be very careful when it comes to your coordinates. When there are, the x comes first. I've been putting the x first. When there is 1 pound, or 1 pound of peanuts, there are, and this is of course repetitive of what we just said, right? 4/10 of a pound of walnuts. And last one, when there are 7.5 pounds, and that's the X, right, which is still peanuts, of peanuts, there are 3 pounds of walnuts. All right, so finding the constant of proportionality, you're finding basically y when x is 1. Then they want you to interpret the constant of proportionality, which is pretty much that. If you want to write it as there's 4/10 pounds of walnuts per pound of peanuts, that'd be okay as like a unit rate. And then the interpretation of the 3 different spots, or the 3 different coordinates on the graph, would be represented like that in sentence form. Okay? Questions on any of those? We have to admit, right? I don't think they're too hard. It's more extra long work than it is difficulty being high, right? More quantity than quality, I guess you'd say, almost, when it comes to difficulty. So, any questions before I have you try one? All right, here's the one I want you guys to try next. I want you to do problem, and it's on the very next page, problem number 9. Problem number 9. Okay, checking in. How many of you are still working on that problem? Okay. Okay, checking in again. How many of you still need more time on that problem? Okay. Let's try about 30 more seconds there. Okay. Hopefully, you guys, those of you that are finished are doing similar problems, okay, to try to get your homework done here. All right, 30 seconds. Go ahead and actually, I'm going to give you guys 1 minute to turn and to share, just because you'll have a lot to share. So 1 minute, go.
For part A, I got the side length is 1 inch, the perimeter is 4 inches. And for part B, I just when the side length is 0 inches, the perimeter is 0 inches. And when the side length is 1 inch, the perimeter is 4 inches. When the side length is 3 inches, the perimeter is 12 inches.
All right, here we go. For number 9, it says the perimeter of a square is proportional to the length of one side as shown in the graph. Well, straight line passing through the origin, it's proportional. So, A, find and interpret the constant of proportionality. Well, the constant of proportionality, right, is when x is 1, what's y? Well, there it is, right there. Y is 4 when x is 1. So our constant of proportionality, I can put it right here, is 4. Maybe I'll move it up here to view the rest of my answer. Okay? And interpretation-wise, you could just say, remember, y is 4. So the perimeter of, and it says of a square, maybe even put the square that they're talking about here. The perimeter, no, I guess it's any square. The perimeter of the square is 4, and it's talking about perimeter, but it's also talking about inches. Inches when a side length is, of course, 1 inch. Okay? So basically constant proportionality and interpretation. Okay? Then it says explain what points 0, 0, 1, 4, and 3, 12 mean. So, or represent. So, here we go. You would say the perimeter of a square is 0 inches, of course, when each side length is 0 inches. The perimeter of a square, we were talking about y first, okay? So this one, since we're talking about y, and I'm talking about this, I'm going to say that the perimeter of a square is 4 inches when the side lengths are 1 inch. And last one, the perimeter of the square is 12 inches when the side lengths are 3 inches. Woo! Okay. Now, really quickly, what I want to talk about just briefly too is that, I mean, on this one, right, if we were to write this, y is equal to 4x, because that's what that is, right? We talked about that. Constant of proportionality is k, so y equals kx. That equation is y equals 4x. You know what that means? That the y is always going to be 4 times as big as the x. Or in this case, the perimeter is always going to be 4 times as big as one of the sides, which makes sense, right? We're talking about a square. So that they didn't ask you to do that. I'm just referring that to relating it to a previous homework assignment. Okay.
Does it matter which order you put the y and the x's in for the interpretation?
No, as long as you put the correct units with it. Does that make sense? So that's a great question. So if I, be careful, because when I got in, you see, I was underlining these for a reason, because you can't put the perimeter of a square is, and don't put like perimeter of a square is 12 inches, right? When the side length is, ooh, wait. Oh, yeah. I'm sorry. The perimeter of a square is, let's say, 1 inch when the side length is 4 inches. You know what I mean? So don't, make sure you're describing your x and your y with the correct description, okay? So, yeah. So, yeah, if you said, right, so flipping it around, you could say the side length of, the side length of a square is 1 inch when the perimeter is 4 inches. That would be okay, too, if you flip-flop your interpretation, as long as the number fits the description in the units, okay? All right, guys, any other questions? That's like me saying, guys, your favorite subject in school is math, or saying, guys, math is your favorite subject, right? I mean, just flip-flop, right? That would, no one's disagreeing with me? I'm glad. Hey, especially after this long writing here. All right, here we go. Shouldn't got us off. Maybe we're just laser focused right now. Let's go ahead and take a look. Same side. All right, we do have one more type of problem on this homework here. Let's take a look at problem number 13. All right, so this is where graph paper comes in. Here we go. It says, complete each table so that the relationship between the two quantities is proportional. Check your work by graphing on the coordinate plane. So they want you to finish the table, and then they want you to turn around and graph it. All right, so I'm going to go ahead and do number 13. And we can call this step 1. Step 1 is, let's go ahead and make this table. You don't have to make the table look pretty. All right, you could say this is the length, knowing that it's the ribbon, and don't forget this is in yards, and the cost, the total cost in dollars. Okay, so we could say, well, when the total cost is $2, we're going to get 5 yards of ribbon. When the total cost is blank, we're going to get 7.5 yards of ribbon. When the total cost is 6, we get blank lengths of ribbon. And when the total cost is blank, we get 25 yards of ribbon. All right? And so this is all part of step 1. Now, watch carefully. With this first one, I'm going to use cross products. So watch. Our rate is a 5 to 2. We want to know, and remember, it's 5 yards to $2. I'm going to go ahead and set my yards on top, my dollars on the bottom. So in this case, I'm trying to figure this one out. Look at 7.5 is in the yards, so 7.5. I need to find out what x is. So here we go. I go ahead and say 2 times 7.5 is equal to 5 times x using cross products. 2 times 7.5 is equal to 5 times x. 7.5 times 2 is 15 equals 5x. And look at this. We don't even need a calculator for this one. Divide both sides by 5 and we get x is equal to 3, which means the cost is $3. Now listen, because there's so much involved in this, on this not on the other lesson, on this lesson, you can mix up, you'll need to use cross products at times, but other times you can actually use elementary school kind of math. So for example, right, if it's $3 at 7.5, how do we get from 3 to 6? Multiply by 2. What about 7.5 times 2 is 15. If you have no idea what I'm talking about, then you can do this. 7.5 times 3 is equivalent to blank times 6. This is all I did. Multiply top and bottom by 2 to get my 15. You can use that because this is a proportional relationship. Watch this. 5 times what is 25? 2 times 5 is 10. Or again, 5 over 2 is equal to 25 over blank. And all I did was multiply top and bottom by 5 to get my 10. Okay? So that's just step 1. You can fill out the chart using either strategy. Okay? Like I said, I'm looking at your homework tonight. Some strategies can be simple elementary school strategies. Other strategies, you'll need to use cross product, 7th, 8th grade strategy. Okay? Now, that is step 1. We completed the chart. Now comes step 2, and that is we need to do a graph. So, because they're all positive quantities, we're only doing quadrant 1. So I don't need to draw the whole coordinate graph, just quadrant 1. Now, with this, a majority of the time, your top will be your x, your bottom is your y. So, with that said, my x is length. I'm going to label these in yards. And this is all part of step 2. My y is cost in dollars. Now listen, I'm looking at my y, and you have to think ahead on this if you've never done a coordinate graph from scratch before. Look at my range. It's between 2 and 10, which if I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I can go by ones. Maybe I just number to save myself time by every 2. 2, 4, 6, 8, 10. Now, ladies and gentlemen, I'm looking at my x's, 25. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is as far as I'm going. I'm not getting a 25 count by ones. So, I can maybe count by 2s. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I guess we could, as long as we put 25 on that piece. Okay. Now, you might have enough room. So, maybe that's what I'm going to do. I'm going to label by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and of course 25 would be right after 24. Now, step 2 was create your graph, right? You could even say that. Create the graph. Step 3, bless you. Let's go ahead and graph the info from the table to the graph. So here we go. When x is 5, y is 2. Now, if you'd like, you can write down the ordered pair if you'd like. You don't have to, as long as you know which one is x and which one's y. When x is 5, y is 2. So when x is 5, which is halfway between 4 and 6, y is 2. Plot my point. When x is 7.5, so 7 is halfway between 6 and 8. 7.5 is halfway between, so it's basically 3/4 of the way to 8, between 6 and 8. So 7, this is 7.5. The cost is 3. So I'm going to go up, graph right about there. When x is 15, y is 6. So when x is 15, halfway between 14 and 16, y is 6. Plot my point right there. And when x is 25, which is at the edge of my paper, y is 10. So at the edge of my paper, I'm going to go up to where y is 10, which is that line right there. Plot my point. Now, ladies and gentlemen, find something that is cardstock, like your log, folder, binder. Make sure you're using a straight edge. Because if I do this and it's crooked, it's going to show a non-proportional relationship. It needs to be straight. And if it's straight and you plotted it correctly, then it should also, because it's proportional, hit the origin. And there's our proportional relationship between the length of the ribbon in yards to the cost when it comes to dollars. Okay, questions on that one? Okay, so the lesson on graphing proportional relationships.